Hello, I'm Adam James, and I had this idea to make a little programming video. I like to do a lot of different things. Programming is one of them, and I wanted to show you a fun little project using Clojure. The goal for this video is to recreate a domain-specific language compiler. Now that sounds a little more complicated than it actually is, particularly considering that I'm just cloning an existing library's functionality in a minimalist sort of sense. This is not meant to be a production project in any way. It really is more for my own practice and the potential edification of anyone who watches this video. Mostly it's just for fun. Without further ado, I'm gonna head into the code now and start explaining what the deal actually is here. The project create a domain-specific language, like I said, that compiles to HTML. The input will be some Clojure data structures. The output will be HTML strings. What is this data structure I'm talking about? It's called Hiccup. Now this is a popular library in the Clojure community. It's really popular in part because it's so simple to understand. Let's say I wanted to create a paragraph tag. It's straightforward enough, but you always have to remember to do the opening and closing tags, and if you have an image tag, you have to remember that it has a property that's a source, and the closing tag is like this. There's not actually a closing image tag. There's all kinds of little things that you have to remember. Hiccup uses Clojure data structures to make this even easier to understand. We can actually create a Hiccup example and use what's called vectors to create the same thing. A successful clone of the Hiccup compiler will take these kinds of data structures and produce the appropriate output here. The keyword here, that becomes the tag. Then the contents of the vector here follow like this. There are also optional maps that you can put in that help you define things like width and height with values. Before I go into the Clojure stuff more deeply, what is Clojure anyway? It is a Lisp language, which means list processor. The main thing to pay attention to wrap your head around it is that it uses what's called a prefix notation. In Python, you would write something with infix notation here, 2 plus 3 plus 5. If I were to write that in Clojure, I have to prefix the functionality I'm going to provide and then pass in the arguments. So 2 plus 3. It will evaluate down here in this handy little thing called a REPL. This form here was sent into the REPL and the result is printed right here. The cool thing about prefix notation like this is you can add any number of arguments and it works just fine. Now that is dependent on the function you do. Functions go here, args go here. Anything inside open paren and close paren are S expressions, and you can nest them. The innermost brackets are evaluated, and then the outermost, and so on. Say I wanted to do 2 times 3 plus 7 divided by 2. I don't know why, but let's suppose I want to. I can evaluate that, and it produces the result. I think it's time to make a little implementation bracket here and get things going. If I clear up the REPL, I can start cooking. The nice thing about the REPL is I can test the code and the functions as I write them and kind of manipulate and work with them interactively. It's a really fun and intuitive way to start building programs once you wrap your head around it. I'm actually going to start by making what's called a namespace. And I give it a name, HC Hiccup Clone .main. Oh, I do have to specify Clojure there. In any substantial project, you will end up most likely with requirements. As an example here, write Clojure.test as t, and I can evaluate that now. And now you see I'm in a different namespace, and I can get any function that's in the test library by using the alias I set here, t/, and then I could take any of these functions. As you're working on a project, especially if it's just the first time you're tackling something, you might not know precisely where to start. And this is absolutely true of any other project I'm working on. This was a little easier because, again, it was a clone of functionality that someone else has produced in a library that exists already. So the specifications and everything weren't too hard. It can be difficult to know where to start. So don't ever feel like these kinds of videos are indicative of knowing exactly what to do all the time. That isn't the case. But in this case, I happen to know that I want to make a predicate function. Predicates are questions that ask something about a piece of data and returns true or false. I'm going to define a function that will become my predicate called Hiccup. The arguments that this will take are item, because it might not be an element particularly. Hiccup, as we specified earlier, looks kind of like this. It's got some key, it's got a optional argument map, and then it has content or nil content. So it could also look like this, some key, some arguments, and nothing else. I am going to be okay with this as a predicate. I want to check that the item is a vector, and I want to check that the first item from the list, from the vector I should say, is in fact a keyword. This is sufficient for my minimal implementation needs. So I can actually run this in the REPL. If I run those, true, true, and let's make one that returns false. That should be false, as we see here, and that's pretty good. What I need to do next is create a way to transform some keys. There's a function built in called string. It can take different strings and basically concatenates the strings. It can also convert different values into strings as well. If I have keyword like this and I string that, it creates the string including the colon at the front here. So I want to make a little function that produces the string that I want without that colon there. And I don't want to import any string libraries or anything like that. I just want to keep the dependencies minimal. I'm going to define key to string as a function here, and it's going to take a key k, and now I'm going to use a let statement and some destructuring. If I return f in this function, key to string, with a key atom, the key gets turned into a string here. And then a string is actually a sequence of characters. So I destructure it by taking and binding the first element in that sequence to the symbol f, and rest then puts the remaining sequence minus the first item into the variable symbol rest. If I put rest here, I actually get close to what I want. I get a sequence of characters. Now what I want to do is apply string to that sequence to get back the string that I want. All I really need to do is put in just a bit of logic, because it is possible that you pass in a key that doesn't have the colon at the start, and I don't want to misname the keys. So I'm just going to have an if here. F is equal to the colon character. Then I want to apply string to rest like I did in the REPL. Otherwise, I want to apply string to the conj of rest and f. So what's going on here? You write if, and then you have to write the conditional check. This form will evaluate either to true or false. If it evaluates to true, it will run this next S expression. If it's false, it will run this S expression. All I'm doing here is taking the colon out if the first character is a colon, and putting it back onto the list if in fact it was just a string. If I run key to string on the key atom, it should give me the string atom without the colon. If I run key to string over the string already, this should make no change. And that is in fact what I see. This is an interesting thing that I wanted to just put in the video to illustrate how the reality of developing goes sometimes. There's actually a function that I didn't know existed that will handle this just exactly the way I need for this case. And that function is name. It gives back exactly the string, and if I run it with a string, it does exactly the same thing. So it turns out that this is completely unnecessary. So I'm going to comment the whole thing out and recognize that I only need to use this function here. One thing as a developer that I've been learning over and over again is that nothing beats reading other people's code for discovering new ways of doing simple things. It's also not something anyone should be ashamed of for not knowing that other functions existed. But it is really nice when you read someone else's code and say, whoa, that's how they did that? I didn't even know that existed. Here we are, a little story there about transforming keys. Turns out I didn't need the function at all. It is great to not need some of the functions you create. It's probably a good idea to start looking at properties. Properties themselves go into Clojure maps, and Clojure maps are key value pairs. And what you can do, you can run the keys as if they're functions over the map. Oh, I forgot to def this. Oh, I've messed up my REPL a little bit there. There we go. So now I can actually take the key A from example map, and it will return for me A, the value that was in that map there. I'm going to make a function and call it compile props. And it's going to take a map M. I'm going to let F be a lambda function or an anonymous function. What I have here is just another function definition. Outside of the scope of this function will no longer exist. That can be really useful for small little transformations that you don't need to necessarily make an entire function for. Now I can use that function in the rest of this approach. So I'm going to use a little macro here that's called the thread last macro. It is one of my favorite macros. The thread last macro will take the first thing you give it here and then thread it through the last argument position of every function that follows. What does that mean? The next expression is map F, but you can imagine it being executed like this: map F over M. Map F over M will map the function F on the sequence of key value pairs in the map. The next line is interpose, and you can imagine it as interpose spaces between the list of items in the map F of M. The next line after that is this special conj thing I've got going on here, which is a bit of an abuse of a different kind of syntax. It's just a nicety for creating the same thing here. Instead of writing function, you write the hash. Percent things become the inputs to the function. So I want conj of whatever gets passed into the function to be the function that I run on all of this. The last thing is apply string to all of this. This line of code here, apply string to conj, interpose, blah, 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 is equivalent to this. And this is why I like the threading macros so much, is they become much easier to reason about. You kind of can understand that I'm starting with a map and I'm doing all of these transformations one after another to it, and then the result comes out of that. Now that I've got this going, let's try to see if it works. I'm going to run compile props on that example map. Typo here. My fat fingers are causing some minor issues. Compile props on example map produces the string that will be placed inside the tag, the opening tag. I actually forgot to handle the situation where one of the properties is style. Hiccup nicely lets you nest another map in there. If I run compile props on example macro now, or pardon me, example map, I get a malformed style here. It won't work. So I need to adjust the approach here. I'm going to do that by splitting out this function that I had originally done anonymously into its own named function called compile prop, call it property for a little bit of clarity there. And I'm going to destructure right away into key value. Take first off of the map, it returns a vector with the key and the value. So you can kind of treat maps as sequences of their key value pairs that then get turned into vectors of the key and the value. To compile a single property, I basically just want to use this approach here in this function. So I'm going to write that now for a moment. Here is a conditional that will change the value of v here. If it's a map, it will run a different function, compile style -v. Otherwise, it will just string the value v. This here is the same as what's up here. If this were a fresh REPL, this would fail to compile because I have not defined the function compile style yet. Let's make compile style exist. I actually am going to use pretty much this whole setup here to do the same kind of thing. Paste it in here and modify it to my needs. When you do inline styles, instead of using equal signs, you need the colon, and instead of ending it with a quote, you end it with a semicolon. I also no longer want to interpose spaces, nor do I want to put a space at the front of the string. I can now finally put it back to create the correct function of compile props that handles the style case. I want to map compile property over m, interpose space between all of those, conj a space at the start of the string. I'm going to test this, compile props on exm now. And in fact, we see inline CSS formatted the way I want it to. So we've got all of the bits and pieces pretty much ready to go. I'd like to now move on to the actual compiler. Okay, what does it need to do? It needs to handle a few different cases. An MTP tag, a situation where you call the compiler with a few elements in the top level like this, a situation like this where you create a list of a bunch of tags. Something that's just a string, combinations of these with properties. Instead of doing proper testing, I just put a bunch of cases that I came up with in my brain, and I will def all of those. Now obviously you'd want to do some more thorough testing than just that for a production situation. Absolutely. That would be the wise thing to do. But we're not being wise today, we're just having fun, so I'm going to let it slide. I mentioned earlier something like an image tag that only has an opening tag, and I'm going to handle that by creating something here called single tag. This is a special kind of data structure called a set, an unordered list of only unique items basically. So what does that mean? Def example set like this, print exs, the set has a 1, a 3, and a 2. Now notice it's, like I said, it's unordered, right? You cannot count on the order of these being the way you might expect. There's a different thing called a sorted set to handle those situations. I only need that because I can use it as a special kind of predicate. The way I implemented this was actually with two functions. So I'm going to declare HTML. Declare is something you don't use too often in Clojure, but what it does is let the compiler and the reader know that this symbol does exist, even though there's no definition for it yet. This is necessary if you have two functions that call each other in your code, because one of the functions will be defined above it and one below it. So you need all the symbols that are used in both functions to exist. Define compile item, and item is going to be any of these situations. Knowing that, I can actually destructure right away the key, everything else being content. Now what I need to do is actually handle something up front here. Props don't exist in my arguments coming in, but they might exist in the item. I'm going to take first of the content. That's the definition of the Hiccup data. It has to be the key, then the optional map, and then everything else. So it's guaranteed to be the first item in the list of content here, if it exists. That's props the map. The props string is when props is a map, compile props of props. That'll create the string that we get from the compile props function. If there's no map, in other words, if there are no properties, this returns nil, which is just fine with me. Let's make the opening tag string. Let's use name k, the clever trick. Props string, which will either have some value or be nil. Use string with something, nil, something else. The nil basically disappears. So I can use that fact to never worry about whether or not props exist. If it does, it'll be in the string. If it doesn't, it's not there. I also want to put into this opening tag the simple logic of when tag k is inside this set, then this predicate is true. Put the closing slash here, and then I can put the closing arrow element like that. And I'm going to write the closing tag, which is a little bit easier. When not single tag k. When you don't need a closing tag, there's no closing tag. Finally, we'll prepare content, which will take if map props, then the content is defined as rest of content. So you drop the map off of the list of content. Otherwise, there is no map, and so content remains unchanged. That is that nice big let statement complete. Now is the time where I can change the behavior of this function a little bit using a conditional. So cond is a special form as well. It has any number of predicates and body and so on, and you can include an else for some default behavior. This is where I'll put in some of the logic that is necessary to make these valid, to correctly compile those things. So let's go at it. The first thing is really quite simple, actually. I'm going to check if content is empty or if it's nil. If the condition is met, I need to do this: string o tag c tag. Let me put a little thing here, no content, a little thing that's called a comment. Now this next situation is where content is just a string wrapped in a list. What I need to do is check if the count of content is 1, and then if the first element of the content is a string. If that's true, all I have to do is string together the opening tag, the first element from content, which is just going to be a string, and then the closing tag. And then the final case here is if I do content is some nested structure. There may in fact be other edge cases that would require other conditionals here, and that's the nice thing about cond is you can just put in more if you need to. The downside of that is it can, if you're not careful, lead to kind of confusing and messy code. For a small project like this, I'm okay with that. I'm going to just finish this one up here by writing HTML content c tag. Here, in the situation where content is a sequence of a few Hiccup elements, I want to apply a new function to it, and that new function is not defined, it is just declared. So I have to produce this HTML function. What HTML will do is compile everything in content using the compile item function. So they are mutually recursive to one another. This HTML function takes any bit of content like this, and this is where the user will be able to use HTML to compile what they want. To do this, I do need to basically handle the same kind of conditions. Function called with a single string. To check that that's the case, count of content to be equal to 1, string of first of content to be true as well. This is mirroring right here if it's a string. Function called with a single Hiccup element. So I'm going to copy this and just change it. Here we finally get to use my Hiccup predicate to check that the first item from the content is in fact a Hiccup element. If it is, we're good to go. And when that's true, you don't want to return content here. You actually want to return the application of compile item to content. And this is where the mutual recursion begins. Function is called with a list of elements. I believe I should be able to use the same approach as a basis. Instead of checking to see if it's a string or if it's Hiccup, we check if it's a sequence. If it is a sequence, now we have to do something slightly different still. We want to apply string to the map of compile item over first of content. Now what's going on here? Here I only had a single element, so I just applied compile item directly to that element. Here I have a whole list of content items, so I have to compile items for everything in the list, and so I just map the function over it, and map returns a sequence. So since compile item returns a string, the sequence of strings needs to be concatenated together. And so I apply string to the sequence of strings to make a single string. The final thing is function is called directly on multiple elements. Apply string to the map of HTML over the content here. And that is all. Let's see if those are actually going to work the way I want them to. A1 is a P tag, works like I wanted. A2 is P tag with something in it, so we'll run that. Has something in it. A3 has a property. There we go. A4, that seems to work. And A5 is an image tag which has no closing tag. So let's run HTML A5, and that has indeed no closing tag. Things are working so far. Let's look at B1, which has a nested structure. There we go. Div, P, div. Beautiful. B2, HTML B2, div, P tag, and then the closing div. Looks good. And B3 is a nested structure with a list inside it. Let's give that a try. Earlier on, I had defined something into variable A, and this is why I'm making this at all, is I like to use SVG for animations and vector graphics and stuff like that. So it's fun to have a little tool that can render it nice and quickly, and so that works just fine with my HTML compiler here as well. That basically concludes producing a minimal compiler for the Hiccup language. This is a drawing that uses SVG, has a bunch of different things here. It's got some transforms, group tags, lines, rectangles. Let's produce a file, drawing.svg. We'll put the compiled HTML of the drawing, I should say, into that file. Spit is a quick way on the Clojure side of things to write text files, basically. Okay, well, that's great. Now I don't see anything. Drawing.svg. There we go. Display some inline images. Boom. I've got I don't know why I drew a dumbbell, but I did. I coded up a minimal implementation of the Hiccup domain-specific language compiler. I've had a good time. I hope you enjoyed this video, and you want to see more of this kind of stuff. I've got more in store. Might be interesting to stay tuned. Feel free to subscribe. Feel free to like the video, comment on it. If you want to check out the GitHub and stuff, I said it earlier, but I'll say it again, that I'm going to have in the links and stuff like that. And if you're a better Clojure programmer than I, that's fantastic. And if you see stuff that I did that was obviously foolish or incomplete, or I missed some functionality that would be helpful, please feel free to let me know. I am not claiming to be perfect at this. I'm just claiming to have a fun time doing it. So thanks for watching. I really appreciate it. And I hope you have a good day or night or time. I am going to head out now. That's all I got. Have a good one.